Hello, today I'm going to go over the notes for lesson 5-2. So this is where we are trying to prove whether two triangles are congruent to each other. And when we do this, remember in lesson 5-1, when we were told that two triangles are congruent, we could determine then that the three different pairs of sides are congruent and three different pairs of angles are congruent. So that's a total of 6 different congruence relationships that we could get from the 3 sides and the 3 angles. It turns out you don't need all 6 of those to be true you don't need to know all 6 in order to determine if both of those two triangles are congruent or not. You really only need 3 pieces of information, but they have to be the right 3 pieces of information. So we're going to work with sides and angles, and we really only need 3 pieces of information. So the 4 different ways to prove congruence, as you already probably know from your pink sheets, is side, 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 angle, side, angle, and angle, angle, side. So notice what is not here. Some of the ones that people get confused on is we do not have SSA or ASS, and you do not have AAA. Neither one of those is going to be possible to prove congruence. Okay, so this is how you're going to want to do this. You're going to want to mark these figures, in my opinion. That really is helpful. So in problem number 1, we see that we have 2 sides with a single slash. So those sides are congruent. S for side. 2 slashes for this pair, that's another side. And then triple slashes, that's another side. So what we have is we have side, side, side congruence. All 3 sides of one triangle are corresponding to 3 sides of another triangle. So that means those 2 triangles are congruent. So here we have angle, 2 angles that are congruent because they have a single arc. We have a side with a single slash, and we have another pair of angles with a double arc. So make sure you're going in the same order. We have an angle, a side, and another angle. So this is called the included side because it's right in between 2 angles that we're talking about. So this is called angle, side, angle, or ASA. Here we have a single slash, a single arc for the angle, and a double slash. So be careful with some of these. This looks like a side, angle, side. We got to make sure it's the same for both. So that was a single slash, a single arc, and a double slash. Here we do not have the same order. It is the angle, the side, and the side. So because these are in a different order means they're not the same, and you cannot prove congruence. So we're going to say none of these 4 apply. So going on to number 4, we have side, another side, and an angle. What do we have here? Side, side, angle. Side, side, angle. And remember, you need to go the shortest way around the triangle. So I have a side, the very next side, and the very next angle. I can't say this is side, angle, side, because I'm going the longer way around, and I just skipped this whole side here. So, do we have the same thing for the other one? Side, side, angle. So yeah, we have side, side, angle, or angle, side, side. Either way, it doesn't work, and again, we cannot prove congruence. For the next problem, number 5, we have a single slash. We have a right angle, which means the 2 angles are congruent. That's only 2 pieces of information, but if you look carefully, you will notice that we have vertical angles. Vertical angles we always know are congruent. We've learned that back in the earlier days of this course. So that means we really do have another angle there that we can mark. So this one you need to be careful again, go around the shortest way possible. The shortest way is not going to be angle, side, angle, because I just skipped this angle right here. It's actually the other way. This is angle, angle, side. Can I do that the other way? So that was the right angle, the single arc, and the single slash. Right angle, single arc, single slash. So that is called angle, angle, side. Okay, so moving on. We have a similar problem for number 6 like we did just now. We have an angle, a side, and then again, oops, these are double arcs. The vertical angles are going to be congruent as well. What do we have here? Angle, side, angle, angle, side, angle. It's the same for both. Number 6, sorry, that was number 6. Number 7, we have a side with a single slash. We have an angle with a single arc. And this is the first instance of a reflexive side. A reflexive side is a side that two triangles share. And we use the reflexive property to say this segment for one triangle is equal to this, or congruent to this segment for the other triangle. So two segments that are the same are going to be congruent, or one segment that's the same is going to be congruent for both triangles. So what do we have here? We have angle, side, side, or side, side, angle. And actually that's not right. Angle, I went the wrong way. Angle, side, side. And then this one would be side, angle, side. So again, different order. And because of that, we cannot prove congruence. For here, we have a single slash, double slash, and then the reflexive side. So that is all three sides, which means side, side, side. Number 9, single slash, double slash, and then vertical angles gives us a single arc. So that's SAS, SAS. So side, angle, side congruence for this one. Okay, that's the first page. On the second page, we're going to do basically the same thing, but a little bit more, because if we can prove that the two triangles are congruent, then we're going to write the congruence statement. That's only when they're congruent. So, and there's a little bit more to do on some of these problems. You have to read the given and then mark it down on your figure, because that wasn't the case on the first page. So here we're told segment LO is congruent to segment LG. I've already got a single slash, so I'm going to use a double slash. LO and LG are congruent, and also segment GN and segment ON are congruent as well. So we got a triple slash. Do we have any triangles that are congruent? I have side, 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 but are they the same? No, they are not. This is a double slash. This is a triple slash. Double, triple. The single slash, of course, is the same. That is the only side that we know is the same. The others are not the same unless we are told more information. And because of that, all I can say is none of these apply, because I don't know that these double slash and triple slash segments are the same length, or that they're congruent. So moving on to the next one, we got sides and vertical angles. So we got side, angle, side, side, angle, side. Yes, that is side, angle, side. And remember, for congruent statements, if they're both blank, you have many different ways you can write the answer, but on the test or the quiz, we will usually fill in one side for you. So I'm going to say triangle ABC. Then I need to figure out the order for the other one. This is how I would do it. Angle A doesn't have any arcs on it, so that makes it a little bit harder. But what you can see is it's between the single slash side and the no slash side. What's the same for the other triangle? Single slash side and no slash side. So P is corresponding to A. B was between the no slash side and the double slash, so that's the same as Q. And then C had the single arc, and so does C over here. So triangle ABC is congruent to triangle PQC, and that is your congruent statement in one of the orders you could have written it in. Again, there's 5 other ways you could have written it in reverse order or moving the letters around in a different order. So let's go on to the next one. Angle 1 and angle 2 are given as congruent, 3 and 4. So I'm going to write a double arc for those. And what else do we know? We know that the reflexive side is congruent. So that is an angle, side, angle, angle, side, angle. This gets a little messy with the A's and the S's. But what do we have? We have angle, angle, side, angle, angle, side, angle. So that's the single arc, the single slash, and the double arc. So for both of these, we have ASA. So what's one of the congruent statements we could have written? WZX goes with, W is the one with no angle arc. The only one for the other triangle is Y. Z is the, for the top triangle, that was the single arc. What's the single arc down here? X. And what is X down here for the first triangle was a double arc, and that corresponds with Z having the double arc. So this is your congruent statement. Triangle WZX is congruent to triangle YXZ. Number 13, we got a right angle, and then we also have the single slash sides, and then we have these vertical angles. So we actually have 3 pieces of information now. The order on this one is important, so make sure you're going in the right order. You cannot say angle, side, angle, because this angle was not being used. You have to go the shortest way possible. You could say side, angle, angle, but really that's not the way we write it. We say angle, angle, side. So here, let's see if that works the other way. Angle, angle, side. Yes, so that is AAS, or angle, angle, side. What is the statement I can write? Let me write the left side, and let's see if we can match it on the right side. MCN. M has the right angle, so does A. C had the single arc, so does C. N was what's left over, which is B. So N didn't have any angle arc, and neither does B. Plus, it's also the third letter you haven't used yet. 14, let's see, we got a side, a reflexive side, and this is where we have to get into the parallel lines. Notice these 2 segments are parallel. Segment AB and segment GC are parallel, and you have this transversal segment AC. Parallel lines, we always have to look out for alternate interior angles. Alternate interior means the angle formed between the transversal and one of the parallel lines. That's one of your alternate interior angles, and here is the other, the parallel line and the transversal. So we know these 2 angles are congruent. So what does that give us? Side, angle, side. That was a single slash, single arc, double slash. Side, angle, side. It's the same exact order. Let's go for triangle ABC and see what is it congruent to. A had the single arc. What has it down here? C. B had nothing. Neither did C though. So we have to be more specific. B was between the single slash side and the no slash side. G is between the single slash side and the no slash side. And then ABC. C was between the no slash side and the double. A would be between the no slash side and the double. So that would be CGA. Number 15, again, we have a given that we need to mark down. We need to mark down that segment BC is congruent to segment DC. Segment AC, meanwhile, is also congruent to segment EC. And what else? We only have two pieces of information. We need to know that these two vertical angles are congruent. So what do we have? Side, angle, side, side, angle, side. Exactly the same order. And let's go for triangle ABC again. ABC. So that's congruent to triangle. A was between the no slash and the double. No slash and double is an E over here. B was between the no slash side and the single, which is the same as D. And then C had the single arc, so does C here. Finally, the last row of problems, we have some more givens. Segment AC is congruent to segment BC. And this is a different one. Segment CD, that vertical segment, is bisecting that big angle ACB. When you bisect an angle, that original big angle gets split into two congruent smaller angles. So I have this angle being congruent to that angle. So I'm going to indicate that with single arcs for each. It's always nice to not write your single arcs in one big arc, because then it's not clear what's going on. So I always stagger them. Also, we had this shared side. Segment CD not only was bisecting, but it's also a reflexive side. So it's shared between the two triangles. So we have side, angle, side. Side, angle, side. And what is a statement I can write? Triangle ACD. And triangle. Okay, so A was between the no slash side and the single slash. So is B. C had the single arc, so does C over here. And D was between the double slash and the no slash. Double slash and the no slash. So it's again D. So ACD and BCD are the orders that we could write. And number 17. It tells you something a little different. Not only are W and Y congruent, but they're actually right angles this time, which is kind of what they look like. Angle W and angle Y look like right angles. And then what? Segment VW is congruent to segment ZY, and X, point X, is the midpoint of WY. Midpoint means it's right smack in the middle, and you got just as much distance on the left as you do on the right. So these two segments must be congruent to each other. So what do we have now? Side, angle, side. Side, angle, side. Go the shortest way possible. Side, angle, side. And then let's come up with a name for this one. Let's call it VWX. And triangle. Let's go for, okay, so V was between the single slash and the no slash. Z is also the same. W was the right angle, so is Y. X is what's left over, but another way of confirming that is it's between the double slash and the no slash. Double slash and no slash. So again, it's X. And there you go. That is your notes for 5-2. Remember, when you're going around the triangle, always go around the shortest way possible. And be particularly careful with AAS problems. Let me go over this one more time. You want to say AAS, because I'm not skipping any angles. I went from one angle to the very next angle, and I went to the very next side. If you had said ASA, you would be wrong, because I skipped this angle, and I should never do that. I always want to go the shortest way possible. Okay, so that's it for notes 5-2.